Welcome. Thank you all for coming to spend the day with us, spend some time with us. We've got a couple more people coming in, but we know it's early, and we're glad that everybody showed up early for this event. So my name is Sundwall. I lead AWS's Open Data program, and I think I've emailed just about everyone here in the room, so it's nice to meet everybody in person, and I'll meet you all throughout the day. I haven't talked to you yet. This is the first event. This is the first sort of big event that our program's done, so we're really excited about it. It's great to see the turnout. Here's my agenda for what I'm going to talk about in my session here. I want to talk a little bit about our open data program, why we have one, and talk a little bit about some of our public data sets. So specifically Nextrat on AWS, which is our most recent public data set that we've launched. These are data sets that we host at our expense. And then of course a lot of you I'm sure are interested in knowing more about Landsat on AWS and what we've learned from that project throughout this year. But before that, I want to do some welcome stuff. I love emoji. First of all, I want to make sure we thank our sponsors for making this event possible. We couldn't have done it without them. A lot of, there are folks from Digital Globe and Esri and Development Seat here. They'll be here throughout the day. So I hope you get to meet them and talk to them and thank them for sponsoring this event. And then I have to give very special thanks to Chief for giving us this space and hosting us and welcoming us here. I've been a huge fan of the Chief team for years. They're really dedicated to pushing things forward in terms of like how the government uses technology and design, which is why they were the first people I thought of when we thought about hosting this event. So thank you so much for having us. Literally best people in the world. No exaggeration. Yes, thank you, Chief. So I want to share with you to make sure you all know like what our goals are for this event. So why are we here? Why did we put on an event like this? Number one, we wanted to show off amazing work that's being done by our customers. Throughout our work on this Landsat on AWS project, we've learned about really astonishing things, I mean, to me astonishing, really groundbreaking stuff that our customers are doing with AWS and with Earth observation data. We wanted to show that off. It's really, it's exciting and fun for us to talk about like what our infrastructure can do in the abstract, but we wanted to provide a venue where people could show off like real work that they're actually doing, real applications of the data. We also want to provide opportunities for you to network. So if you look at the agenda, you'll notice there are 15-minute breaks after every 2 sessions. So you're gonna learn a lot. There's gonna be a lot of content throughout the day, but we want to make sure that there's time. There are plenty of breaks so that you can get up and meet each other and talk and have conversations. And check your email if you have to, but hopefully have networking events. And then the other thing is we've told all the speakers that they all have half-hour slots, and that includes time to take questions too. So we don't expect people to fill up that half hour with just lecture, but also to take questions. So we really hope that today ends up being a very conversational day for everybody. Another goal that we had is we wanted to show off the diversity of work being done with Earth observation data. There are a lot of, the presenters are working in different fields and different arenas, and they're looking at similar data, the same data, but from different angles. They're taking different approaches. And so my hope is that all the presenters will learn from one another, and that everybody in here will be able to learn from one another and come home with some sort of new insight or new approach to looking at problems that they might not have had before. Hopefully there'll be a mixing and cross-pollination of ideas. And then finally, there's for us at Amazon Web Services, we want to know a little bit more about what your priorities and needs are. I know that a lot of people have been doing the Post-it note survey that we have going, which again, thank you, Chief, for helping us set that up. It looks really cool to find out what sort of data products in terms of Earth observation products are you most interested in, would you be able to work with. You'll also notice though that on all of your seats there's a survey. We ask you please fill out that survey. We'd like to do more events like this, so we'd like to get your feedback on this event. And then also on that survey, you can also vote for your favorite Earth observation data. Okay, so and then the other thing I want to say just really quickly is we do have, and I think some of you have picked this up, this is a new white paper. We just published this last week, I think like on Friday. We wanted to make sure we got it done for this event. It's a white paper describing how you can share data using Amazon S3 and use a feature that we have called Requester Pays that allows you to share the cost of data transfer with people who request that data. And so it's a feature that is a lot of people don't know about, and so we wanted to explain that in a white paper very clearly, because we get this question a lot on how you can use S3 to share data, but while avoiding variable costs that come with that. So please pick that up and let us know if you have any questions about it or thoughts on that. Okay, so I'm going to talk a little bit about the open data program at AWS and explain sort of why we have one. So in the first case, we want to ask this question: why does AWS care about open data? And in short, it's because it matters to our customers. We have a lot of customers whose products would not exist without access to high quality government information. So it matters to our customers, therefore it matters to us. And so if we can help our customers who rely on this data get better access to it, that's something that we want to do. Like as a program, what we work to do is to make more data more available to more people all the time, just increase access to data. And the other thing is that another way we describe it is that having high quality data out there and available to people is kind of like oxygen in the atmosphere for our infrastructure. It gives people stuff to do with our servers and database services and things like that. And speaking of that, so we have a comprehensive toolkit for working with data at any scale. So we have a lot of products, and I'm not going to talk about like specifically our products today, but I want to underscore the fact that we're very well equipped and equipped very specifically actually to work with massive amounts of data at very large scale. And then I think this also helps answer another question, which is, it's easy for us to say why we care about open data, but there's another question: is why should open data, or why does the cloud matter to open data? What does the cloud bring to open data? And so in this case, yes, we have a lot of products and services to work with data. We also have a marketplace, very full marketplace that is loaded full of applications to visualize data, to integrate it, to manage it, and so forth. So not only can you get computing resources, but you can also get software as well. And then beyond that, there's a very, very basic, and it sounds simplistic, but this is true. When data is made available in the cloud, the data is close to our computers. Okay, so it's just having data closer to computers is actually very significant, especially when we're talking about data sets that are very heavy, like Earth observation data or sensor data that is already very large and is growing in volume very rapidly. What this means is that people can bring their algorithms to the data rather than taking the data to their algorithms. And we'll talk about this a lot when we talk about the Landsat data, for instance, is that we've learned that there's really valuable data that people simply can't work with because the barrier to acquiring it and the barrier to storing it themselves is just too high. Very few people have access to the local storage to be able to work with the data. So making data available in the cloud really enables people to work with the data at a dramatically lower cost than they ever could before. And there are a few other things. I'm going to go through a few other sort of benefits of AWS and of the cloud that explain why when you put data in the cloud, it becomes quite a bit more powerful. Another one is that we have over 1 million customers, and so a lot of these include partners that specifically serve the public sector. You're going to hear from some of those partners today. I know it's a very busy slide, but you can see Harris, I know, who's going to be presenting here, and Esri, who will also be presenting here on the slide. Forgive me if I missed anyone else who's here. But anyway, we have a lot of customers, and so what this means is that there's a rich ecosystem of developers that are ready, that are familiar with our platform, and are ready and equipped to work with data once it's made available here. And then we also are continually innovating. So again, if the data is in the cloud, it benefits year after year of us adding more and more features to our platform. So we're continually adding new features. We currently have over 40 services, and we can support virtually any kind of workload, and that just gets better and better. So the data becomes more valuable over time because there are more tools for people to work with it. And then finally, we're always dropping prices. All right, so we have a good long history of price reduction on our platform. Whenever we're able to realize some sort of benefit from our scale and derive some greater efficiency from our services, we pass that saving along to the customer as soon as we can. And so the barriers to working with the data, the barriers to doing heavy analysis just become lower and lower year after year as we drop our prices. So those are our ecosystem of customers, the continual price reduction, the continual addition of new services are some of the reasons why we feel like the cloud is really a great place to store data and to unlock its potential and ensure that it gets used and used effectively. So that's our platform and why we really care about open data. Now I want to share a few thoughts on how we approach open data and how we think about it as a program and as a team. So this is a graph that I borrowed from Socrata with their permission. I swear. I always mention them when I show this because I feel bad about it a little bit, but not that bad. So where we take this idea of like how can we take a single data point or some sort of static data and make it into something valuable? What happens? And so the idea is that you'll take a data point, it's data at rest, and you move it along two vectors, these vectors of sense making and data enrichment. And so I'll use a couple examples to explain what that means and why this matters. So first of all, so you can take a data point like today's low temperature, right? That's an interesting data point. It becomes more interesting when you actually know where we're talking about, right? So you take just one number, it could be 50 something degrees. That's only valuable if you know like the location that you're talking about. So right there, you've enriched the data by taking a number and adding a geographic location. Now that data still is not enough for me to know like what I should wear throughout the day. So you take the low temperature, you want to combine that with the high temperature as well, right? So you get a range, that's something that I can understand, I can make a decision based on that. If you enrich that even further with precipitation forecast, I can make even a more sophisticated decision. And then if I'm a farmer or a gardener, I can combine that information with plant hardiness. Okay, so I know what this information needs for my assets, right? Or like crops in the field. And so just right there, with that very simple example of data that we're used to consuming every day, they're pointing out how sophisticated that is. So we're able to understand, to ingest a lot of information that is created through a pretty complex process, but then we get it on our phones, and the information sort of feels like it's free to us. We take it completely for granted, but it's actually a very sophisticated set of data that we're able to understand. And so as more and more data becomes available to people when it's open, and when it's easy for people to get access to, and as software gets better, and as interfaces get better, we're able to know things that we couldn't know before. And this lowers the cost of knowledge. This lowers the cost of us being able to know what we need to know to make key decisions about our lives or our businesses. I read a really good story from a couple weeks ago. I'm sure it was like the Landsat program retweeted it or something like that, but it's about the Great Grain Robbery of 1972. Has anybody heard this story before? Okay, good. All shaking heads. This is a great story. So in 1972, thick of the Cold War, we still had plenty of trade with Russia. Like commodities trading was still going along perfectly fine. And Russia, between July and August of 1972, bought 10 million tons of American wheat. And we had plenty of subsidies for farmers. And so they were able to get this wheat at a discount. Just due to our subsidies. American wheat was cheap and affordable, and they bought a ton, and we're like, great, it's fine. Like we sold wheat all the time. They were experiencing crop failure due to bad weather, you could say some poor policy decisions, and so we sold off all this grain, but what we didn't realize was happening at the time is that there was actually a global weather crisis and a global crop failure that we were dealing with. And suddenly we had a food shortage at home, we had a huge spike in food prices, and there was a crisis. Coincidentally, it really is a coincidence, 1972 was the first year, that's when Landsat 1 launched. And so we could not know, it was not knowable what the global crop inventory was. It was not knowable, the cost of knowing these things was prohibitive. Nobody could know this, that there was a global crisis going on at that time. And now today we can take for granted the fact that we can know more or less what the global crop inventory is at any given time. Okay, it's really remarkable. I mean, that's not a lot of time that's passed, and that's like a massive change in the amount of knowledge that we have available to us, and at very low cost. So that's how we think about this. That's how we sort of think about the value of open data and what that does for the world. And also, we have products that we provide for every step of the way. This is intended not necessarily to like pitch you all right now, but it's really a way that we think about our products in the terms of our program and in terms of like when we want to serve people who work with open data. which is that we do have products that help with the creation of data. Obviously, the storing and sharing of data that's there in the corner is Amazon S3 that we'll be talking about a little bit today. And then we have all of our server and database products. Now, so I want to talk a little bit about how we approach open data. And hopefully this is useful for some of our customers from the government who are here that are in charge of open data programs. So we have two sort of very Amazonian ideas that we think about when we approach data sets. And one is called working backwards from the customer and eliminating undifferentiated heavy lifting. So what does this mean? So first of all, working backwards, whenever we're thinking about a new product, and we consider data sets like the data sets that we host through our public data sets program, we think of those as products. So whenever we think about any sort of product or building any sort of new project, there's a trick that we do within Amazon, which is we'll write a hypothetical press release before you even get started. So if you've formed the idea in your mind, you're like, okay, this might be a good idea. Then you sit down, you write a press release. And what the challenge, it's a great filter for your ideas because you're faced with the challenge of writing about a page of plain language describing why anybody would care. And if you can't do it, if it's not plausible, you maybe should focus on something else, or you need to think a little bit harder about it. But it really is a filter. It helps us figure out what are the things that we can really work on that really matter, and does this make sense? And so we think about that when we approach public data sets. The other thing we think about is this idea of undifferentiated heavy lifting. Undifferentiated heavy lifting is all of the stuff that you have to do within your organization that keeps you from getting to the stuff that you actually want to do, keeps you from actually fulfilling your mission. And so if you think about AWS in these terms, it's very easy to see like, okay, we want to take off the burden of people buying and unboxing servers, powering them, securing them, cooling them, et cetera, keeping them up to date. We are able to manage that for you. That's one of the benefits of the cloud, is that you can procure server capacity instantaneously over the internet. But the same thing applies to data. And so there's this quote from this book called Data Driven, which is it's actually free on the Kindle if you want. It's like 30 pages or something like that. It's more of a pamphlet. But by DJ Patil and Hillary Mason. And DJ is I'm sure a lot of you know, is the chief data scientist of the United States right now. So this idea that 80% of a data scientist's work goes into the cleaning up data or acquiring it. If anything, it's larger than that. Especially when, to those of you in the room who are used to working with satellite data or very heavy data sets, there's so much time that just goes into acquiring the data. So when we're thinking about data sets, we think, well, so how can we attack that 80%? How can we get rid of that for people? So those are just two ideas that explain sort of how we approach these things and approach these data sets and set our priorities. Which is a great segue into me talking a little bit about our public data sets. So our public data sets program is a program we use where we host data at our expense for our customers. And the data sets that we choose are largely based on customer demand. But we also choose data sets when we want to do something. It's sort of like a lab for us, and we want to explore hosting new kinds of data that hasn't been hosted in the cloud before, or address new markets that haven't been using the cloud yet. And so first of all, we're going to talk about Nextrad on AWS. This is our newest public data set. We just launched it last month. Ariel Gold in the back, in the gold-orange shirt, worked really hard on this project. I'm going to force everybody to give her a round of applause. This project was huge. Yeah, like it. I guess you guys don't know why you're clapping. I mean, she worked so hard to make this happen. This data has never been available before. So Nextrad, for those of you who don't know, it's a set of 160 radar, like high-resolution Doppler radar sites throughout the country. We now make available a real-time feed of data from the radar stations, as well as archival data going all the way back to 1991. And this is now all available as objects within Amazon S3. This is how we do it. So we get the data straight from the sites. We make it available in S3 in real time. We then do some assembly into chunks of data that we make available in an archive. I'm pretty sure I said that right. But if you Google Nextrad AWS, you'll be able to find documentation on it. But this data at this volume and at this scale it's just never been available this way. In particular, the archive has never really been available to anyone. It's been secured away on tapes. And to underscore this notion that we do have a large ecosystem of customers, we worked with a lot of customers. We worked with Unidata, the Weather Company, the Climate Corporation, and CartoDB on this project to figure out again, what is that 80% of work that goes into acquiring and staging this data, making it ready for analysis, and what can we do to make it really easy for people to work with? And yeah, this is the website here, but again, if you just Google Nextrat AWS, you'll be able to find this. There are tutorials that the Climate Corporation and CartoDB have created to show off how people can get started working with this data right now, which is very exciting. And I want to add, we've heard from at least one customer since we launched this last month that having the data available in this way allowed them to complete a project 2 weeks earlier than they would have otherwise. Okay, so think of 2 weeks of a team of data scientists' salaries saved. We're really, really happy about that. Okay, so Landsat. Everyone loves Landsat. Who loves Landsat? Yay. Yes, okay, that's great. This is the response I expected. So Landsat on AWS. We launched in March of this year. It was about this time last year I was writing the sort of the business case for this within the company. And we announced in December of last year that we would host up to a petabyte of Landsat data on AWS over the course of 2 years. And so we started bringing on all Landsat 8 scenes that are produced in 2015, and we also have about 50,000 scenes, cloudless scenes, from 2013 and 2014. Planet Labs works with us on the data pipeline here, and we bring in about 700 scenes a day as soon as they're produced. And so to explain, again, this working backwards approach and this eliminating undifferentiated heavy lifting approach, we talked to a lot of our customers who use Landsat data, and we learned that acquiring it was a real pain, to put it lightly. It was always a bottleneck. It was very hard for them to determine which scenes would be available to them instantaneously, and even the scenes that were available, like how long it would take to get them. And one of the things that we learned, or the other thing that we learned, is that a lot of people didn't work with Landsat as much as they could because of that limitation of acquisition, and that there were also a lot of people that they were limited by how much local storage they had. They couldn't get their IT departments to give them many terabytes of data that they wanted to work with a lot of Landsat data. And so we listened to these customers and we realized, okay, we can solve a few problems for everybody all at once. And so one, the acquisition problem. So we can make the data available close to computing resources in the cloud. That's easy. But the other thing that we learned is that the way that you would get Landsat data traditionally is you get a tar ball, you get a tar archive from USGS, and that includes all of the data for each scene. So all spectral data for the scene is made available in 12 different GeoTIFF files. And that's pretty big. So it ends up being about 1 gigabyte. But what we learned is that most of the people that work with the data, they need about 3 or 4 bands at a time. So they'll spend a ton of time downloading 1 gigabyte of data, and then they'll throw away 60-70% of the data. And so that's 60 to 70% of the time, which is a real burden when acquiring this data, is just wasted time. And so what we do is we bring in the archives, we send them to EC2, one of our virtual servers, unpack the tarball, make each TIFF available as a standalone file, and we make that available on S3 as a standalone object. And so what this does is it allows people to just use a URL to get the scenes that they want, or get precisely the data they want from the scene. The other thing we do is we put internal tiling on the TIFFs. So what this allows you to do is you can do what's called a range get over HTTP, which means that if you want to get just part of an object, you can. So you don't have to get the entire scene, the entire GeoTIFF. You can say, I want, for instance, on here, it's something like pixels like 19 to 27. You can actually say that. I only want this part of the file. And what that allows you to do with this internal tiling is that you can zero in on just like a field, for instance, or like a forest, the particular part of the planet that you're looking at. And so it allows for much more efficient access to the data. It's much faster. Okay, and that makes a huge difference when you're working at scale, when you're talking about accessing millions of objects. And so what this has allowed is the creation of all sorts of cool tools. These are composites that I made with a tool called Snapsat, which was built by a group of students, 5 students who had just learned how to code. They launched this a few weeks after we launched Landsat on AWS, and it's tremendous. They're able to do it because they didn't have to worry about acquiring or storing the data themselves. Go to snapsat.org, it's the best. It's a really cool site. Really cool interface to navigate the planet and make composites of Landsat data literally like within seconds, which is it's astonishing. You can just do it all, and it's all done in the cloud. And the lesson here is that when you're sharing data, when you think about sharing data, think about sharing URLs rather than sharing copies of the data. A lot of people are used to, I was talking to Jerry a little bit ago about ordering tapes, right? Like it's still common, moving data around on tapes or shipping disks and things like that. You don't need to do that anymore. You can share URLs. And then really quickly, I want to wrap up here because I'm going too long. I don't want to set a bad example for everybody else. But I wanted to share some numbers about Landsat on AWS. So the response has been overwhelming. It's been really, really great. I've been telling people I feel like the dog that's caught the car. I really don't know what to do at this point because the success of Landsat has been so great. So we launched this in March. Within 150 days, we logged well over half a billion requests for data out of S3. And I have to add the caveat, we've never launched a data set sort of comparable to Landsat before, so we don't really know what the baseline is. But what we do know is that this is a very large number. We're really excited to see that there's this much demand, there's demand of this volume, that it's consistent. We know that the data is being used not on accident, and of course, the demos that you're gonna see today, you're gonna realize how purposeful people are being with this data and how it's allowing them to do stuff they couldn't have ever done before. And then I also want to thank you, Drew. Thanks to Drew, who's in the audience here. He made this visualization for me within like 24 hours. I asked him for a very quick turnaround. He did it for me, so thank you, Drew. And then I just want to show off this thing. Again, remember this graph. Like this is how this looks actually in practice, where you have the data being created, the data being shared, from a static repository in the cloud, and it's enabled all this sort of work to grow out of it. And you're going to learn about that throughout the day. One more thing, we've been testing this out. We now have a public SNS topic. So this is for those of you who are building applications on AWS that are familiar with simple notification service. I don't expect you to write this down or anything like that, but send me an email if you want it. You can now subscribe to this topic from any AWS account, and you'll be able to be notified whenever we complete a new batch of Landsat data and make it available on S3, which is great because then you can you can have your applications automatically start doing work as soon as the data lands in the bucket. So thank you very much for your time. Again, thank you for coming out. I'm really, really happy to see so many people here, and we've got a great lineup. Thanks so much.